starting on chapter 3, we're going to talk about the measure of the center and the variations. So basically, we're going to focus on chapter 3, we're going to focus on center, variation, distribution, outliers, and time. So CVDOT, those 5 most important characteristics of any data set. Chapter 1, we talk about the difference between the population and sample. Sample comes from the population. A sample is a subset of the population. Population includes every single member of the content we try to investigate. And perimeter used to describe the characteristics of the population. Statistics is used to capture the characteristics of the sample. And the good sampling methods, we talk about sampling methods like simple random sample and random sample. In chapter 2, we talk about frequency distributions, and I also learn how to construct a histogram, pie chart, all those different graphs. So we summarize the data with the graphs. Describing the center, variation, distribution, outliers, and changing of characteristics over time. So we call that CVDOT. Introduce on that. Okay. And starting on chapter 3, we're going to start talk about descriptive statistics. So statistics has 2 major branches. The first branch is the descriptive statistics. The other branch is the inferential statistics. Now, in chapter 3, we're going to mainly focus on descriptive statistics. We're going to talk about the center, variation. So basically CVDOT, center, variation, distribution, outliers, and time. Okay. And let's get started on measure of the center. So for any data set, we need to pay attention to center. And we use a couple important terms called mean, median, mode, all those different terms to capture the center. Also, we try to interpret those values, right? Like the value for center, for median, for mean, for mode. Okay. Now, first of all, let's take a look at the measure of the center. We use a specific value, the value at the center or the middle of the data set. Okay. So we could use a mean. Mean could be an important tool to capture the center. So mean is the measure of the center obtained by adding the values and dividing the total by the number of the values. We use this formula, sample mean x bar equal to summation of x, sum up all the data values in your data set, divided by the sample size. And also people call that average. Mean is the same thing as average. You can also call that arithmetic mean. Now let's look at some important notations. First notation is the summation sign. This is what they call the summation sign. And summation sign indicates sum up all the data values, or find the sum of all the data values in your data set. X represented each individual variable, each individual data values. Okay, so it's a variable used to representing the individual data values. N is the sample size. We call this sample size, represent number of data values in the sample. You can just easily call that sample size. And the capital letter N represent number of the data values in the population. You can also call that population size. Okay, so now first of all, let's take a look at sample mean. Sample mean is equal to summation of x. So sum up all the data values in your sample and divide by the sample size. And mu is what we call the population mean. This is population mean. This is sample mean. Population mean equal to summation of x. You sum up every single data value in the population and dividing by population size. Okay. So just different notations. So pay attention to those notations. anytime if you see this lowercase n, that means you're talking about the sample mean. Uppercase n, that indicates we are solving for the population mean. So the advantage of using the mean, sample means true from the same population tend to be very less than other measure of the center. Also, we take every data value into consideration. That's the advantage of that, of the mean. Disadvantage is very sensitive to the outliers, extreme values, sensitive to the outliers. Also, you can say that extreme values or outliers has big impact. Have a big impact on the mean. So sometimes they'll make it less reliable, because if you have an outlier in your data set, then your mean will not be an objective representative of the center. Now let's take a look at this. Table 3.1 includes counts of chocolate chips in different cookies. Find the mean of first 5 counts of chips. Cookies, 22 chips, 22 chips, 26, 24, and 23. So in order to find the mean, we do x bar, right, equals summation of x divided by sample size. Summation of x indicating you add up all those data values. So 22, adding 22, adding 26, 24, 23, and dividing by 5. And so the sample size here, sample size in this case, we're picking 5 cookies, so sample size is 5. So this turned out to be 117 by 5. And that's approximately equal to 117 by 5. $23.5. So the mean average chips in any one of the cookies is 23.4 chips. All right, so that's how we solve for the sample mean. And then second important measurement to capture the center is what we call the median. Median is the middle value when the original data set is arranging in the increasing order, right? So you tally the data, put it in the increasing order, and then the middle value is what we call the median. We usually use this symbol x tilde to represent this is pronunciation, x tilde, to representing the median. And median is not so much affected by extreme values. So that means median is less sensitive to the extreme values or the outliers. Okay, so if in the case of having an extreme value or outlier in the data set, so you probably would prefer to use median to capture the center. Now, in order to find the median, we have 2 scenarios. First of all, you arrange them in the increasing order, right? Arrange the data set in increasing order, meaning you start with the smallest value, go all the way to largest value. And also, if the number of data values is odd, meaning sample size is odd, when the sample size is odd, then the exam middle, the median is located in the exam middle. Okay, so the middle one is the median. Sample size is odd, then the middle value is the median. And this is the first scenario when it's odd. And if the number of data values is even, then the median must be computed by adding the middle two and divide by 2. So averaging the middle two basically. So you're averaging, if the sample size is even, then the median is the average of the middle two. Middle two values. Okay. Now let's take a look at the example. Let's take a look at this data set. We have 7 data values, right? So 7 is the R number, 7 data value. And first step, you're going to put into the increasing order. Start with the smallest value, 0.42. Then move on to next value, 0.48. If you want, you can close out the data values you picked, right? And move on to the next number, 0.66. Close out that. Move on to next one, 0.71, 73. And then move on to next two repeating numbers, 1.0, 1.10, and 1.10. Last number is 5.40. Okay, so we include all 7 numbers. Since we have odd amount of data values, so median is right in the middle. So x tilde median, x tilde is equal to 0.73. Although we have extreme values here, if you look at it, 5.4 compared to the most of the numbers look like extreme values. Since we're using the middle values, so our extreme value has very minimal impact on the median, on the calculation of the median. Okay. Now let's take a look at another example. We have, in this case, we have even amount data values, 6 data values. So this is another scenario. Again, we're going to sort the data, put into the increasing order. So 0.42 goes first, then 0.48, 0.73, 1.0, 1.0, 1.10, 1.10. The last data value is 5.40. Now you look at the middle two, right? Since the sample size is even, so we average the middle two. So x tilde median, x tilde equal to the average of middle two, 0.73, adding 1.10 divided by 2. So that's 1.83 by 2. And this turned out to be 0.915. Okay. All right, so that tells you how to find a median for 2 different cases. Right. And then the mode is the third important term we use to capture the center. Mode is the data value that appears most frequently, so occurs most frequently. Okay. Data set can have one or more than one mode or no mode. Okay, so we have some terminology. If 2 data value appears most frequently, right, then we call that bimodal. If more than 2 data values appears most frequently, then we call that multimodal. If no data value is repeated, so every single data value appears once, then we say there's no mode. Okay. And mode is only measured of the central tendency, only one measure of the central tendency. And it's most effective with the categorical data. So meaning we have a categorical data, then mode becomes only measurement we can use to capture the center, because we wouldn't be able to find a mean and median for the categorical data. Okay, so now let's take a look at this. Let's find out the mode for these different problems. First one, we have 6 data values and 1.1 appears twice. So that's the mode, right? The mode is 1.1 because 1.1 appears twice, which appears most frequently. And second data set, we have a 27 and then 55. Those two appears most frequently, appear 3 times. So we call this bimodal. And if you look at the third part, that every single number appears once or occur once, so we call this no mode. So the third one has no mode. The mid-range is the value midway between the maximum and minimum value in the original data set. So mid-range is equal to maximum plus minimum and divided by 2. So it's easier just to sort the data in increasing order, and you find the minimum and maximum right away, which is the first number and last number in your tallied data set. Also, minimum is very sensitive to the outlier, to the extreme value, because you are including the smallest value and the largest value in your data set. Those two could be potential outliers or extreme values. So that's why mid-range is very sensitive to the extreme values. Sensitive to extreme values because it only uses minimum and maximum values. And also it's very easy to compute the mid-range. And typically, if you feel like the mid-range is not a good representative of the center, you should also consider other measurement like mean, median, mode. So there are several ways to define the center besides the mid-range. So also there's median is totally different from the mid-range. The way how we calculate that, we're using totally different formulas to calculate that. So avoid the confusion between the median and the mid-range. Okay. And round-off rules for the measure of center. So you just carry one more decimal places than the original data value. Meaning if the original data value is appear in, let's say, one decimal place, then all this mean, median, mode must be run into 2 decimal place. Two decimal place. Okay, so that's the round-off rule for all of those. So now sometimes you have to consider whether the results are reasonable. Say you calculate the mean, median, mode, but you need to be able to explain it, interpret it. So for example, like this, we have 2 different examples here: rank by sales of selected statistical textbook. So here we can calculate the mean. Mean x bar equals summation of x over sample size. So sum up all of those numbers, 1 plus 4 plus 3 plus 2 plus 15. Then you get a divide by 5. Sample size is 5. And this turned out to be 25 over 5. That's 5. And right here, 5 is the average of those numbers. However, we just couldn't explain this 5, right, in terms of the ranking system here. So no real meaning. Same thing for median here, right? The median, if you put the data in the increasing order, it'll be 1, 2, 3, 4, 15. And then the median is 3. Median x tilde 3. And again, it's very difficult to interpret this median in a real sense. That's why sometimes, you calculate mean, median, but it has no real meaning. Okay. And also numbers of on the jerseys of starting offense for the New Orleans Saints when the last won the Super Bowl. Yeah, all those are the jersey numbers, and you average all those jersey numbers, or you find the middle of those jersey numbers, and there's no, it's impossible to interpret in the real sense. So again, you can find a mean, median, but in these cases, you won't be able to find a meaningful interpretation about those. All right, so now let's take a look at some applications of the measure of the center. First one is calculating the mean from the frequency distribution. So we learned the frequency distribution in chapter 2. So the formula is x sample mean for the frequency distribution equals summation of f represent individual frequency for each class. X represent the midpoint. And summation of f actually means the sample size. Total frequency means the sample size. Same thing. Okay, that's interpretation of those symbols. And then for each individual frequency times midpoint, you get all those product, and then you sum up all those product. That becomes numerator. Denominator is the total frequencies. You can also call that sample size. So if you go back to the IQ score examples we talk about in chapter 2, we have 5 classes, and we have corresponding frequencies. And first of all, we need to find a class midpoint. So the first class midpoint, you add in the lower limit 50, add in 69 divided by 2, you get 59.5. So which is the same thing as 119 by 2 becomes 59.5. And same thing for second one, you add in 70 by 89 divided by 2, you get a midpoint, 79.5. Again, the increment is 20, so you add in 20 to the previous one, you get the next one. You can apply the pattern to all these class midpoints. And the next midpoint is 90 plus 109 by 2. Okay, look at that. 110 plus 129 by 2, you get a midpoint. Last one, 130 plus 149 by 2. Look at that. Now you get all the midpoint. Now, in order to get a product, you multiply the frequency by the midpoint. So 2 times 59.5, that becomes 119.0. And 33, okay, times 79.5, that becomes 2,623.5. You can verify that easily. 35 times 99.5, look at that. 7 times 119.5, okay, 136.5. 1 times 139.5, you get 139.5. Now you sum up all these product, right? Then it turned out to be a 7,201, which is this underneath it. And that becomes a numerator, you know, to calculate the mean. Denominator is total frequency, so you're going to sum up all these frequencies. Adding 2 by 33, get 35, adding 35, 70, adding 7, 77, 77, adding 1, 78. So total frequency, which is sample size, in this case is 78. Now you get the sum of the product, sum of the frequencies, and to find the quotient of those two. 7,201 divided by 78, and get 92.3. Okay, that's how you find the mean from the frequency distribution table. So then basically set up the table, create 2 more columns, get a class midpoint first, find the product, sum up all the products, and then sum up all the frequencies. And use a formula, you get the mean for the frequency distribution table. And also weighting mean, another important application of the mean. So data value assigned different weights. We call that W. W represents a weight. We can compute the weighting mean by sample mean equals summation of W times X over summation of W. So GPA, right? GPA is important application of the weighted mean. Important application. And next example, I'm going to show you how to calculate the GPA. Of the weighted mean. Okay, so keep note on the formula, and let's take a look at this. So in first semester of college, a student of the author took 5 courses. Her final grades, along with the number of credits for each course, were A, 3 credit, another A, 4 credit, B, 3 credit, getting a C with 3 credits, getting an F with 1 credit, and then the grading system assigns quality points. So this is important. Quality points is what we call X, right? Okay. To letter grades as follows. All right, so now you have 5 courses. So let's create a table, right? So first of all, let's put in a W weight and an X. We need one more column, W times X. Okay. So for the first course, it's 3 credits. So weight is the number of credits for each course. So 3 credits. Second course is 4 credit. Third course 3 credit. Fourth course 3 credit. The last course will be 1 credit. Okay. Now X represented quality points for A. First course is an A, so 4 point. Right. Second course is an A, 4 point. Third course is a B, so 3 point. Fourth course is a C. C is 2 point. Last course is F, 0 point. Now all you need to do is finding the product of those two. So W times X, 3 times 4 is 12. 4 times 4 is 16. 3 times 3, 9. 3 times 2 is 6. 1 times 0, 0. Now in order to calculate the weighting mean, sample mean equal to summation of W times X over summation of W. So you need to sum up 2 things. Sum up so you get the total of the weight, total credits, 7, 10, 14, right? 14 credits. And you also sum up the product. 12 plus 16, 28, adding 9, 37, adding 6, 43. All right, so now you basically just find the quotient of those two, 43 by 14. And let's run it to 2 decimal place. 43 by 14 turn out to be 3.07. So the GPA for her first semester of college will be 3.07. And creating the table, this table method will help you a lot, right? First of all, it keep you organized. Also, you'll be able to check all detailed calculations through the table. So the table is very highly recommended. And this is just next slide, just show you how to do it. You get the same result, 3.07.